Okay, in this video, I'm going to be reviewing a few of the questions from our rational expressions test review, starting with number 9. We have 6 over 2x squared minus 50 times x squared plus 11x plus 30 divided by x squared minus 10, all divided by x squared plus 16x plus 60 over 4x cubed minus 400x. All right, the first thing I'm going to do is I'm going to go ahead and factor and simplify all of these fractions or rational functions. So this first one, 6 over 2x squared minus 50. 2x squared minus 50 will start by factoring out the 2. That will leave us x squared minus 25. Well, this is the difference of two squares. So ultimately, that becomes 2 times x plus 5 times x minus 5. This middle fraction, we factor this trinomial to x plus 5 times x plus 6, all over x minus 10. And then, of course, divided by x plus 10 times x plus 6 over. And then when we factor this, we factor out the 4x first, and we get x squared minus 100. But then x squared minus 100 is the difference of squares. So 4x times x plus 10, x minus 10. All right, now, the first thing you need to be sure to do is to consider your denominators. And anything that would create a 0 in the denominator needs to be identified as part of the domain restriction, okay? So this x plus 5, we would not be able to input a negative 5. X minus 5, we would not be able to input a 5. And x minus 10, we would not be able to input a 10. And then over here, the x plus 10, again, we would not be able to input a negative 10. And here, x minus 10, we would not be able to input a positive 10. Also, the 4 times x cannot equal 0, so 4 times 0. So we have to consider that 0 as well, all in our domain, okay? Now, let's go ahead and work this out. 6 over 2 times x plus 5, x minus 5 is going to end up as 3 over x plus 5, x minus 5, because 6 divided by 2 is 3. And then we have these other fractions, x plus 5, x plus 6 over x minus 10 times, and then, well, this is division, so we multiply by the reciprocal. So this third fraction here on the right is being flipped. And then what we do is we start looking for common factors in the numerator and denominator. So you see I marked out x plus 5 and x plus 5. That went away. We already accounted for the negative 5 that would create that hole. So that's part of our domain. X plus 6 and x plus 6 we marked out. Now, with x plus 6 being a common factor, then we know that x cannot equal, and that actually should say negative 6 right there. It cannot equal negative 6. All right, so, and then we go back, so we mark that out, and then we have an x minus 10 and x minus 10 that we get rid of, and an x plus 10 and an x plus 10. All we have left is 3 times 4x, which is 12x, and then the denominator x minus 5. So that's actually our simplified expression. But our domain considers all of these input values that would create holes, okay, or errors or asymptotes. So this is all of them right here. All right, now let's take a look at number 10. So number 10, this is all multiplication. The first thing I'm going to do is I'm going to start factoring all of my expressions and then simplifying. So this first one, the numerator is x minus 10, but the denominator gets factored into x minus 10, x minus 7 times, and then this numerator becomes x minus 9 times x minus 7, all over x minus 9, and then times. I simplified 6 over 3x to 2 over x, because 6 divided by 3 is 2. Now, again, when I consider my domain, anything in the denominator that would become a 0 needs to be identified as an input value that would create a hole. So this x minus 10, the x value 10 cannot, our function can equal anything that's not equal to 10. X minus 7 would mean we cannot use a 7. X minus 9, we cannot input a 9. And, of course, when you just have a number over x, if x is in the denominator, x cannot equal 0, okay? And then when we go ahead and work this out, you can see that we can cancel out the common factor of x minus 10, as well as x minus 7. I've shown you that on here, as well as x minus 9. Now, all of those values have been accounted for already. In terms of the whole, we just end up with 2 over x. So that's our simplified expression. And then I would put all of the, this is the domain that would be included. All right. Now let's take a look at number 11. Okay, so this is a subtraction problem, okay? Now, you're also not being asked about the domain or anything on this one, all right? But you do have to subtract, and we have to find a common denominator. Now, this first fraction just has a factor of x minus 3, and the second one has a factor of x minus 2. So we'll simply just represent those as multiplied together as the common denominator. Well, if the fraction on the left, the current denominator includes the factor x plus 3, but it does not include the factor x minus 2, so we have to multiply the numerator x times x minus 2. And then minus 5, the 5 has a denominator of x minus 2, but the common denominator also includes x plus 3, so we have to multiply that minus 5 times x plus 3. When we do the multiplication up here, x times x is x squared, x times negative 2 is minus 2x. And then we have minus 5 times x, which is minus 5x, and minus 5 times 3 is minus 15, okay? Then we have to combine these like terms. We get x squared minus 7x minus 15. And I notice right away that I'm not going to be able to factor this, so there's not going to be any common factors to address or to take out, to simplify. So I'm just going to go ahead and multiply now my denominator. Instead of writing it as in factored form, I just do the FOILing, and I got x squared plus x minus 6, and that would be our solution. Okay, number 12, this is an addition problem, okay? It's very similar. We're looking for a common denominator. Each one has a factor. They're different. We have an x minus 4 and an x plus 8, so we're just going to call that our common denominator. So what we're going to need to do then is the fraction on the left that has a numerator of 2x plus 3 is going to have to be multiplied by the x plus 8. So here, I show that up here. Then we add 3, and it has to be multiplied by the factor it does not currently have, which is the x minus 4. All right? Now, when we work that out, we do have to FOIL these two, 2x plus 3 times x plus 8. That's where you get 2x squared plus 19x plus 24. Then 3 times x is 3x, and 3 times negative 4 is minus 12. Okay? All of that over our common denominator of x minus 4 times x plus 8. Then we combine our like terms, and we have 2x squared plus 22x plus 12. I notice again here that I can't really simplify that. I could take out a 2, or I could simplify it, but it doesn't give me any common factors with my denominator factors of x minus 4, x plus 8. So these are not going to change or anything like that. So we'll simply write our answer as 2x squared plus 22x plus 12 in the numerator, and then x squared plus 4x minus 32, which is our factors FOILed. All right. Let's go ahead and take a look at number 13 here. So this is an addition problem. It's a little bit different with our denominator. You see here that the 7x has a denominator of x plus 1. And then plus 7 over x squared minus 1. Well, the first thing we want to go ahead and do is factor our denominator into x plus 1 times x minus 1. This is the difference of two squares, and that's how we factor that. Well, you'll notice they now share a factor of x plus 1. So in our common denominator, we only have to account for that factor one time, x plus 1, and then x minus 1. So that's our common factor, or our least common denominator, which makes it the common denominator that we're going to use, okay? So 7x already has that factor of x plus 1, but we need to multiply it by the x minus 1. So I'm showing that up here, 7x times x minus 1. And then plus 7, because 7 already has the common denominator that we're using, so it doesn't change at all, right? Now, over here, I've just done the multiplication. 7x times x is 7x squared, and 7x times negative 1 is minus 7x, and then, of course, we have our plus 7, okay? And then I notice here that I could try to factor out the 7, but it's not going to leave me with a trinomial that I can factor to find out if there's any common factors in the numerator and denominator, so everything is going to stay. So 7x squared minus 7x plus 7 divided by, and then this is x squared minus 1, which was that original common denominator. And that's how you answer that one. All right, 14. So on number 14, we have a x plus 5 divided by or over x squared minus 2x minus 15. So I factored that trinomial into x minus 5, x plus 3, and then I subtract 1 over x minus 5. You can see that they share this factor of x minus 5, but then there's a factor of x plus 3. So the common denominator is going to be the x minus 5, x plus 3. Therefore, this first fraction is not going to be adjusted at all. It's x plus 5. But the minus 1 will be multiplied by the x plus 3 that is not part of the its original denominator. So minus 1 times x plus 3. You can see I've shown that up here and then all over the common denominator. Now, when you arrow over, or when I come over here, I just did the multiplication, x plus 5, and then minus 1 times x is minus x, and then minus 1 times 3 is minus 3. All right? Then it was just a matter of my like terms. Well, I have an x minus x, so they basically canceled each other out. And then 5 minus 3 is 2. And then obviously I'm not going to have any common factors, so I just go ahead and multiply these factors in the denominator and call it x squared minus 2x minus 15.